Hello learners, welcome to this session of Business Mathematics. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Our today's topic is quadratic equation. I've divided this whole course into two modules. This is the brief outline of this module. In this module, we will be starting with the introduction to quadratic equation. Then we will see what are the various methods of solving quadratic equation. We will see two methods. First is the graphical method. Second is the factorization method in this first module. So let's begin this module. This is a definition of quadratic equation. An equation, when reduced to a rational integral form, contains the square of the unknown quantity and no higher power, is called a quadratic equation or equation of second degree. In other words, we can say that any equation having the highest power of unknown variables as 2 is called a quadratic equation. This is the general structure of a quadratic equation, which is ax square plus bx plus c is equal to 0. Here, the value of this coefficient a should not be equal to 0. If a is 0, this whole part will become 0 and our equation becomes a 1-degree equation, which is not a quadratic equation, which is a linear equation. So for a quadratic equation, it is having a form ax square plus bx plus c is equal to 0 and this a is not equal to 0. This form is called a complete quadratic equation, or we can also say that it is add factor. Now, if the value of b is 0, then this equation reduces to ax square plus c is equal to 0. This is called a perfect quadratic equation. Let us see this with an example. We have 3x square minus 5x plus 2 is equal to 0. It is of the form ax square plus bx plus c is equal to 0. The second equation, 4x square minus 9 is equal to 0. It is of the form ax square plus c is equal to 0. Now, there are certain quadratic equations which generally doesn't look apparently as quadratic, but after solving them for some time, they turn out to be a quadratic equation. For example, we have an equation under root of 3x minus 2 plus root of x is equal to 2. Here, the highest power is 1 by 2, so this is not a quadratic equation now, it is a radical equation. Let us now solve this. So we have 3x minus 2 under root is equal to 2 minus root x. I have separated this and I have bring this root x to right hand side. Now, on squaring both the sides, we have under root of 3x minus 2 whole square, which is equal to 2 minus root x whole square. It is of the form a minus b whole square, which is a square plus b square minus twice of ab. So we have 3x minus 2 because under root 3x minus 2 whole square is equal to 3x minus 2. So we have 4 plus x minus 4 times root x. On solving further, we are getting 2x minus 6 is equal to minus of 4 root x. Now again squaring both the sides, we have 2x minus 6 whole square minus of 4 root x whole square. This left hand side is again of the form a minus b whole square. On again expanding, we have 4x square plus 36 minus of 24x is equal to 16x. On solving further, we have the equation x square minus x plus 9 is equal to 0. If we compare this equation with our general form, it is of the form ax square plus bx plus c equal to 0. Now this is a quadratic equation. So we have two types of quadratic equation which are generally apparently from seeing them you can say that they are quadratic, either on a complete quadratic form or a perfect quadratic form, and we have certain equations that at a certain point of time in solution change into a quadratic form. Now we see various methods of solving quadratic equation. Broadly classified, quadratic equation can be solved using two methods. First is a graphical method and second is algebraic method. This algebraic method is again further classified into factorization method and completing a perfect square method. First we start with the graphical method. As the name suggests, we make use of graph, that is we plot a graph on the basis of given equation and we find out the point of intersection. This is a brief description of it. First, we equate the given equation to a variable say y because our equation generally is in terms of x. Now put different values of x and we obtain different values of y. On plotting these points on a graph paper, we get a parabola. Now the point of intersection of this parabola with the x-axis gives the two values of x to us, or we can say two roots. Let us see it with an example. Suppose we are given y is equal to x square minus 4x plus 1 as our equation. Now here, putting the different values of x, we are calculating different values of y. On putting x and y on a graph paper, we have these points and we join these points, we will get a parabola. This type of curve figure is called a parabola. Now, here this parabola cuts this x-axis at this point and this point. Okay, the x value of these 2 points is actually the root of this equation. Now we begin with the first important method of algebraic type. This is a factorization method. To factor or factorize a quadratic equation is to find out what to multiply in order to get the quadratic equation. Let us understand this concept further. Suppose we are multiplying two factors. First is x plus 4, the second is x minus 1 together. This is called expanding. And on expansion of these two by multiplication, we are getting this quadratic equation. That means x plus 4 multiplied by x minus 1, this is called a factor. And if I expand it, if I open the bracket and solve it, I'll get the equation. This is called expansion. The opposite of this is a factorization. So what we do now, from the given equation, we are trying to find out the factors from which we can break this equation in terms of the factors. So factorization method is generally used where the quadratic expression can be easily resolved into its factors. So if you can easily resolve or break this given equation in terms of its factors, we make use of factorization method. Now there are rules to find factorization. The first rule of factorization is that if there are any common factors, that means there are some common factors among the variables that are used in an equation. For example, we have 6x square minus 2x is equal to 0. Now in this equation, what happens? We have term of x here, we have term of x in second term as well, right? So I can take x as common. Also, this 6 is a multiple of 2, so we can take 2 as common as well. That means here 6 and 2 have a common factor of 2, so we can have, first we will take 2 as common. We are left with 3x square minus x is equal to 0. Now we also have x as common, so we'll take x as common as well. So we are left with 2 times x. Inside the bracket, we have 3x minus 1 equating to 0. Now here we have two terms. Either this 2x is equal to 0 or the value of 3x minus 1 is equal to 0. That means we say that we have two factors of this equation. The first factor is twice of x. The second factor is 3x minus 1. Since they both are equating to 0, so first we equate 2x to 0. That means the value of x is equal to 0. If we equate 3x minus 1 to 0, we will get the value of x as 1 by 3. That means we have two roots of this equation. First is x equal to 0. Second is x equal to 1 by 3. This method is called factorization method. Now, the second rule, if there are no common factors. In the previous one, we have common factors, so we easily take common out of it. But in second case, there are no common factors. Now, how to solve the problems? Let us take an example. If we have an equation of the form ax square plus bx plus c is equal to 0, the first step is to find two numbers that multiply to give AC. That means I have to multiply this first and third term, a x square plus bx plus c. This equation is given to us. We have to multiply the coefficient of a with coefficient of c, right? So we have AC. In other words, we can say that a times c. And these two, a and c, together if you add them, they will give b, our middle term. Okay? So we have, suppose an example, we have 2x square plus 7x plus 3 is equal to 0. Now in comparing with the general form, the value of a is 2, the value of b is 7 and the value of c is 3. Now what I'll do, I'll multiply this 3 with 2, which comes out to be 6. Now on adding, that means what I have to do, I have to add these two values to get the value of b as 7. Okay, so I can write this 6 in the form of its multiples as 1 into 6 or 6 into 1. If together I'll add them both, I'll get the answer as 7. So what I will looking for? We want two numbers such that if we multiply them, we'll get the answer as 6. If we add them, I will get the answer as 7. That means the factors of 6 are 1, 2, 3 and 6. That means 1 into 6 or 6 into 1 will generate our answer, that is 7. Okay. Now we rewrite this middle term, this given middle term in terms of these factors. So we rewrite this 7x with 6x and 1x, so that my equation becomes 2x square plus 6x plus x plus 3 is equal to 0. If you add these two, you will get the middle term, that is 7x. Okay. Now the third step. Factor the first two and the last two terms separately. That means we will take a pair of first two terms and we will take a pair of last two terms and try to find out the common factors among them. So here, From the first two terms, I'll take 2x as common, so I'm left with x plus 3. I can take 1 as common, I'm again left with x plus 3. If you closely observe, we have x plus 3 here as well as we have x plus 3 in the second term. So taking this x plus 3 as common, we are left with 2x plus 1. Now, these x plus 3 and 2x plus 1 are the required factors for our equation. What we do next, we simply equate them to 0. If I equate x plus 3 to 0, I'll get the value of x as minus of 3, and if I equate 2x plus 1 to 0, I will get the value as minus of 1 by 2. Hence, we have the root as x equal to minus 1 by 2 and x equal to minus 3. Let us take another example. We have 6x square plus 5x minus 6 equal to 0 as our equation. Now here what we need to do, first we need to multiply these two. Our answer is minus of 36. We will find out the multiples of 36 in terms of its multiples divisors as 1, 2, 3, 4, 6, 9, 12, 18 and 36 to obtain the total of the two divisors as 5, right? So we have 9 and 4. If we do minus 4 into 9, we get minus 36. If we do again minus 4 plus 9, I will get the middle term 5, right? So we take minus of 4 and 9 here. Now rewriting this 5x as the middle term in terms of the factors minus 4 and 9 as minus of 4x plus of 9x. So our equation becomes 6x square minus of 4x plus of 9x minus 6, it is equal to 0. This is understood that here we have equal to 0. Now the first two factors and the last two factors we will take common out of this. So from first two factors we have twice of x, so we are left with 3x minus 2 plus we take 3 as common, so we are left with 3x minus 2. This is equal to 0. Now what we'll do, we'll again take 3x minus 2 as common, so we have 3x minus 2 and 2x plus 3 as two factors. If we equate them to 0, we will get the value of x as minus 3 by 2 and x equal to 2 by 3. Hence the root of this equation is x equal to minus 3 by 2 and x equal to 2 by 3. We take another example. We have x square minus 6x plus 8 is equal to 0. Now here again we multiply this 2, we get 8. We have to obtain 6 here. So we know that the factors 4 and 2 will give this answer as 6. So we will write it as x square minus of 2x minus 4x plus 8, it is equal to 0. It is understood that there is zeroism. Now we have x into x minus 2 because we have taken x as common from first two. Then we have taken minus of 4 as common, so we are left with x minus 2. This is equal to 0. Now we have x minus 4, x minus 2 as the two factors. That means the value of x is equal to 4 and the value of x is equal to 2. Hence root of this equation is x equal to 4 and x equal to 2. Now sometimes problem is like this. Suppose we have 2x plus 1 and we have x plus 3 minus 3 is equal to 0. Apparently this is not a quadratic, but after opening the bracket it will turn out to be a quadratic value. On solving this, on opening the brackets, we have 2x square plus 6x plus x plus 3 minus 3 is equal to 0. On solving further, we are having the value as 2x square plus 7x is equal to 0. Now here, taking x as common, we have x and we have 2x plus 7. If we equate x to 0, the answer is 0. If we equate x to the second term to 0, we are getting 2x plus 7 is equal to 0. That means the value of x is equal to minus of 7 by 2. Hence we have two roots. The first root is x equal to 0. The second root is x equal to minus 7 by 2. Let us see another example. Here we have x square minus of 10x square plus 9 is equal to 0. This equation is not a quadratic equation because the highest degree of this equation is 4. Now we will try to reduce this into a quadratic form for solving it. Let us see how. So we substitute that, let y is equal to x square. So our equation reduces to y square minus 10y plus 9 is equal to 0. This is a quadratic equation. We will use factorization method to solve it. So we will reduce this in terms of its factor. So we are having it like this. Y into y minus 9 minus of y minus 9 is equal to 0. We'll take y minus 9 as common. We are left with y minus 1 as 0. Now here we have two factors. Either we equate this to 0 or this to 0. So we have two values of y. First is 9, second is 1. But this is not our answer because our unknown quantity in the question is x. So we have to find the value of x. We have substituted initially that y is equal to x square. That means the value of x would be under root of y. So we have two values, x is equal to plus minus 3. In the same manner, x square is equal to y is equal to 1. That means the value of x is under root of 1, which is plus minus 1. So we have two roots. First is x equal to plus minus 3. Second, x equal to plus minus 1. Now, this is a word problem. Divide 25 into two parts such that sum of its reciprocals is 1 by 6. The question is, we have to divide number 25 into two parts such that sum of its reciprocals is 1 by 6. Now, what we substitute? We substitute that let the two parts be x and y. According to the given condition, this x plus y should be equal to 25, right? Mark it as equation number 1. Now, we have y is equal to 25 minus x. From this equation, we can say that the value of y is 25 minus x. According to given condition, the sum of the reciprocals is 1 by 6. That means 1 upon x plus 1 upon y is equal to 1 by 6. So we have 1 upon x plus 1 upon 25 minus y is equal to 1 by 6. On solving further, we have it like this. So it is 25 minus x plus x divided by x multiplied by 25 minus x, it is equal to 1 by 6. On solving further, we have 25 divided by x multiplied by 25 minus x is equal to 1 by 6. On solving further, using cross multiplication, we have 150 is equal to 25x minus x square, which is x square minus 25x plus 150 is equal to 0. This is our quadratic equation. Here, we have to substitute it by x. So it is like this. Now, we will solve it using factorization. So we have its factors as like this. So we have two values of x. First value is 10, second value is 15. Hence, the two parts are 10 and 15. Let us now look back what we have covered so far. We have seen what is the concept of quadratic equation. We have seen methods to solve quadratic equation. We have seen graphical method, factorization, and we have seen some practice problem on it. In this first module, we have covered these topics. In the next module, we will be looking some more methods to find quadratic equation and some practice problem. Till then, happy learning. Thank you.